Okay, so the second type of probability distribution we're going to talk about for continuous random variables is the normal probability distribution. It's the most commonly used probability distribution when describing continuous random variables, and it's probably something you're familiar with. We've already talked about it in this course. It's this figure right here. It's the bell-shaped curve. So when you hear about the bell-shaped curve, we're talking about the normal probability distribution. So what is this? Why is it so special? Well, there's a lot of characteristics about it that describe its shape, what it's like, but it is common because a lot of our variables we assume are normally distributed when we're doing statistics, especially inferential statistics. So it is important for statistics, but for right now we're just going to talk about its characteristics. So the entire family of normal distributions is differentiated by two parameters, the mean mu and the standard deviation sigma. So again, the mean is a measure of central tendency, and the standard deviation, right, is a measure of dispersion and how wide and how variable your data are. The highest point on the normal curve is at the mean, which is also the median and the mode of the distribution. So again, the mean, right, for a normal curve is always equal to the median and the mode. Number 3, the mean of the distribution can be any numerical value. It can be negative, it can be 0, it can be positive. Let's look at an example in the figure where the normal distribution has the same standard deviations, but different means. So in this figure over here, right, these distributions, they're all normal distributions. They all have the same standard deviation, but they have different means. So this one has a mean of -10, this one 0, and this one 20. The normal distribution is symmetric, with the shape of the normal curve to the left of the mean is a mirror image of the shape of the normal curve to the right of the mean. The tail of the normal curve extends to infinity in both directions and theoretically never touches the horizontal axis. Because it is symmetric, the normal distribution is not skewed. Its skewness measure is 0. So you remember with these have no skew. A skew would mean that it skews and then it has like a long tail over here. Remember we talked about positively, negatively skewed or skewed to the right or left. Right? Normal distribution has no skew. The standard deviation determines how flat and wide the normal curve is. Larger values of the standard deviation result in wider, flatter curves showing more variability in the data. So here we can look at another figure. So these both of these are normal distributions. They have the same mean, but they have different standard deviations. So the black curve you can see here, its standard deviation is 10, whereas the blue one is 5. So it makes sense that the black curve has a larger standard deviation because it has more variability, right? It extends all the way over here and all the way over here, whereas for the blue curve, right, most of its data are located much closer to this mean value overall. There's less dispersion. And then probabilities for the normal random variable are given by area. Areas under the normal curve, the total area under the curve, right, is 1. Because the distribution is symmetric, the area under the curve to the left of the mean is 0.5, and the area under the curve to the right of the mean is 0.5. For the normal distributions, we can also talk about the normal distribution in terms of probability of data falling within 1, 2, and 3 standard deviations of the mean. So most of the data, right, are closest to the mean, right? They fall within 1 standard deviation of the mean, right? Approximately 68% of the data fall within 1 standard deviation, right? Approximately 95% fall within 2 standard deviations of the mean, and then about almost 98% of the data fall within 3 standard deviations above the mean, so both below and above. And then the last thing about the normal probability distribution is we actually have what's called the standard normal probability distribution. So what this is it's the same thing in terms of a normal distribution. It looks just like this, right? It has that bell-shaped curve, it's symmetric, all the properties we talked about before, but with a standard normal distribution, right, it has a mean of 0 and a standard deviation of 1. Right, this is a standard, and it's called standard because it has a mean of 0 and a standard deviation of 1. So you can think about, well, do all normal distributions have a mean of 0 and standard deviation of 1? No. Think about the mean age of a group of people, right, your age average wouldn't be 0. You can think about the average height of people or average IQ of people, right? You're going to have different values other than Z. But what you can do is you can take any type of normally distributed data set and you can standardize it to make it have a mean of 0 and a standard deviation of 1, which we're going to talk about actually in the next video for understanding how to calculate probabilities for the normal probability distribution.